Xparticles domain object is used for creating liquids, fire and smoke effects inside of Cinema 4D using the Xparticles toolset. In this video we're going to not only look at the Xparticles domain but also the tools used to create these effects such as modifiers and tags. Let's select the domain and add it to our scene. By default the Xparticles domain is set to a 400 by 400 grid and to the liquids mode. If we look at the domain objects tab, we have type liquid, gas and particles gas. These do different things. Let's start with the liquids. First we have weak springs and a strength modifier. This lets you keep your particles together like a constraint. We have a vorticity, viscosity, and then we look at the bounds. The bounds are the actual voxels within inside of the grid. So we can change the grid size, we can change the offsets and the voxel size. Each solver has a walls setting, and the walls are the edges of the boundary. You can disable these, which would mean particles can flow through the walls. The solver gives you options for retiming, such as slowing it down or speeding it up, accuracy of the solve, how many iterations. The pick flip option gives you control over changing the blend between a pick solver and a flip solver. Each do different things. Maximum substeps are the substeps within the calculations. Adaptive is for the bounds. We have tabs for exclusions such as emitters. We have a groups tag for groups within the modifiers. We have modifiers to be excluded and colliders to be excluded. Source objects as well. Then we have a tab for display. The display gives you options to look at things like the voxels. So you can see all the voxels within inside the grid, and this is a good way to see if any collision objects are going to leak and how your sim is working. You can see the adaptive bounds, which when generating will show a white box around your simulation. You can see velocity, which will give you a speed gradient based on the speed of the voxels. You can see colliders, and then we have properties such as temperature, smoke and fire together, fuel and speed. Then a couple of options on how to control those. So let's have a look at setting up a liquid simulation. First thing we need is an emitter, and also we want some gravity within the scene. So go to modifiers, motion, and add a gravity modifier. We can move this guy to the side. With the emitter we're going to change it to a sphere, lower the radius slightly, and change the direction from normal to -y. I'm going to change the display settings just so it's easier to see in the viewport to squares, and we're going to change the color mode to gradient and speed. Pushing play, you'll see you get an instant fluid. Now we left one of the walls unchecked, so you can see the fluids are flowing outside of the wall. So go back to the domain and just re-enable that wall. Now we have our liquid simulation going. We can have a look at putting in more particles. Go back to your emitter, emissions, and we'll change it to 10,000. So we're now getting a nice fast liquid simulation. You can cache this and then work further on, and you can add in collision objects. Let's have a look at doing that now. Select the sphere, right click on the sphere object and add a collider tag. Push play, and you can see it's working as a collision object. These can be animated to create splashes and things like that. So that's a quick look at the liquids. What you can do is add further domains. Change the radius of this a little bit, and I'm going to turn the top wall off on this one and the wall we had off previous on this one. So the particles will now flow from one domain into the next domain. Let's have a look at setting up smoke and fire. I'm going to remove these from the file, get back our default domain, and I'm going to change the type from liquid to gas. I'm going to disable weak springs, and what we'll do is we'll lower the size. The size of the grid is going to tell you how much memory is used, and the smaller you have the grid, the less memory is used and the faster it will work in the viewport. So let's go 1 by 200 by 100 and change the voxel size down to something like 8. We can select any objects to be a source. So we scale this down, we're going to right click on it and choose xparticles, the xparticles domain, and this domain tag gives you options for temperature, fire, pressure, smoke and fuel. These are all settings that you need to create the right environment for something to catch on fire or be smoky. If we go to our domain, go to the display tag and look at the properties. Let's look at temperature for a start. If we push play, you'll see we're getting some temperature display happening inside the scene. Now it's not doing a lot because we haven't given it any buoyancy. So the way to add buoyancy is go to your modifiers, motion, and choose the XP gaseous modifier. This modifier has options to add buoyancy to your scene and also controls over the emission temperatures for smoke, pressure and fire. If we push play now, you'll get a rising smoke simulation. Let's add in some cooling so it's not so fast, 90%, and lower the rise. Let's try 30. We're going to go back to the domain and we're going to change the temperature alpha so that we can see it more clearly in the viewport. Go back to the objects and lower our voxels down to a smaller number such as 5. The smaller the voxels, the more memory, but the more detail you'll receive. Let's just move the gas icon out of the way. Push play. So you can see it's starting to cool a lot faster than it was previously. We can go even higher on that. Let's say 110%. We put some variation into it and add some dispersion to the smoke. Back to our domain, and we can go even lower on our voxels because it's still playing nice and smooth in the viewport. And the lower we go, the more detail we'll get. Let's add some vorticity into the file. So you can see we're getting some nice detail happening. The smoke is dispersing nicely up the top here as it cools down. And we can move around quite nicely in our viewport. If you go back to the domain object, to the display, you can have a look at other properties such as smoke, how the smoke looks within the scene, fire, or fire and smoke. And fire and smoke will render together nicely as well. You can also see the velocity around your objects as it's going. Let's have a look at just temperature again and how we would render this. The way to render this is to choose the Create Shader xparticles gaseous material, and this can go directly onto a domain. With it selected, you have options to render both fire or smoke. Let's turn fire off. In the smoke channel, we want to get smoke from temperature. That's what we're looking at in the viewport. Now we can render that, and it's rendering what you see as the temperature display. If we go back to smoke, it is going to render what you would see if you had the property set to smoke. So you can render that as well. Or you can take your shader and you can turn off smoke and render the fire. Each option has full control over what you're doing with your shader. You have different types of color profiles for the black bodies, temperature from as fire or any of the channels, and then you control how it looks in the render. You also have a texture slot in both fire and smoke. The texture slot gives you advected UVs, so you can add more detail into the render. For example, if we add noise on top of our shader and render it, you'll see you now get more detail in the actual render, and this detail will follow the simulation because it's advected UVs. The other way to use the system is using an emitter. Let's get an X particles emitter object, change it to a sphere, lower it down, and again we'll just change our display so that we can see it better. Our emissions slightly higher. The way the emitter works is it has a tab called extended data, and inside here you have options for adding your temperature and smoke. So again, if we want temperature, we add it in. I don't want to see the temperature display on the domain anymore because I want to look at my particles. Push play, and you see you now have particles getting that information and doing the simulation.